Hey everyone, welcome back to the channel. I am Sanjai Kumar. Today I am going to share something that completely changed the way I diagnose Oracle database performance issues. After 15 years as an Oracle DBA, I have handled hundreds of production incidents and I kept noticing the same pattern again and again. Teams would spend hours analyzing AWR reports and still miss the actual problem. A typical AWR report can be dozens of pages long. Most DBAs feel confused. They don't know where to start. They read everything but still don't see what really matters. Let me share a real story. One night around 2 am, I got a call from a banking client. Their core system was down. Customers could not log in. ATMs were timing out. The business was losing money every minute. I opened the AWR report. Within 5 minutes, I had the root cause. Today, I am going to teach you the exact method I used. By the end of this video, you will be able to diagnose most Oracle performance issues in under 5 minutes. And as a bonus, I have also created an AWR Auto-Triage SQL script that automates this entire process. I will walk you through it step by step and you can download it from the link in the description. Alright, let's get started. Here is what a typical AWR report looks like. Let me scroll through this. You will see sections like instance activity stats pages, table of contents pages, report summary pages, load profile stats pages, instance efficiency pages, top 5 timed foreground events stats pages, CPU usage per second stats pages, memory stats pages, time model stats pages, and it just keeps going and going and going. Now, here is something important that most people don't tell you. Most of this data is noise. In a real production incident, you don't have time to go through everything. You need quick answers. You need to know, is there actually a problem? What type of problem is it? Where exactly is the problem? Which SQL is causing it? And what objects are affected? That's it. Just 5 questions. And the good news is there are 5 specific sections in the AWR report that can answer all of them. I call this the top 5 rule. In the next part, I will walk you through each of these sections and then we will look at a real production issue and apply this method step by step. Let's get into it. Let's start with section 1, load profile. You will usually find this on page number 2 of the AWR report. Now, in this entire section, there is one metric that matters more than anything else. Right here, DB time per transaction. This single number can tell you whether your database has a problem or not. Here is a simple rule you can remember. If DB time per transaction is less than 1 second, your system is healthy. If DB time per transaction is between 1 and 3 seconds, it is a warning sign. Something needs attention. And if DB time per transaction is more than 3 seconds, you are in crisis situation. and you need to act immediately. Let me show you a few real examples. Example number 1, healthy system. Here is a healthy e-commerce database. DB time per transaction is 0.3 seconds. That is excellent. Users are getting fast, near instant responses, so no action is needed here. Example number 2, warning zone. Now here is a data warehouse system that needs attention. DB time per transaction is 2.1 seconds. This falls into the warning zone. Reports may take a few seconds longer than expected. It is not a critical yet, but definitely something to investigate. Example number 3, crisis. And now here is the banking system I mentioned earlier. DB time per transaction is 8.7 seconds. That is a full-blown protection crisis. And if you look at DB time per second, it is 139.8. Let me explain what that actually means. A DB time per second of 139.8 means the database is doing about 140 seconds of work every single second. Sounds impossible, right? But here is the reason. DB time is the sum of the time across all active sessions. So if you have 140 sessions all waiting or working at the same time, you end up with 140 seconds of DB time in just 1 second of real time. So what does this tell us? It tells us there is a massive pile up of sessions. Everything is stuck and each transaction is taking 8.7 seconds instead of the healthy target of under 1 second. But here is the key point. The load profile tells us that there is a problem. It does not tell us why. To find the root cause, we move to section 2. Now let's move to section 2. Top 5 time foreground events. This section tells you what type of problem you are dealing with. Here is what it typically looks like. Now most DBAs look at this and feel confused. But here is the key idea. You don't need to analyze everything. You just focus on one thing, the top event, the first row. That's it. In this example, the top event is row log contention, contributing to about 82% of DB time. Now, here is a simple way to interpret these events. Think of it like a quick decoder. If you see DB file sequential read, it usually points to an index IO issue. If you see DB file scattered read, it indicates full table scans. If you see log file sync, it often means too many commits or redo issues. If you see row log contention, it is a locking or design problem. And if CPU time is very high, it usually means inefficient SQL. Now let's go back to our banking example. The top event is row log contention at 82%. What does that mean? It means sessions are waiting for logs. One session is holding a log and many others are queued up behind it. So this is clearly not an I/O issue. It is not a CPU issue either. This is a locking problem. Now let me show you a different scenario. Here is a data warehouse system. The top event here is DB file scattered read at around 68%. This is a completely different type of problem. Scattered reads usually mean full table scans. In simple terms, the database is scanning entire tables instead of using indexes. Possible causes: missing indexes, outdated stats, or inefficient SQL queries. Now see how powerful this is. Just one section, just one metric, and you immediately understand the type of problem. But we still don't know which SQL is causing it. That's what we will uncover in section 3. Now let's move to section 3. SQL order by elapsed time. This section shows you the top SQL statements ranked by how much total time they consume. But here is something most DBAs get wrong. Don't start by reading the SQL text. Instead, focus on two key columns first: executions, elapsed time per executions. These two numbers can tell you almost everything you need to know. Here is how to interpret them. High executions, low elapsed time equal to death by 8,000 cuts. It means individually fast, but too many executions create a big load. Low executions, high elapsed time equal to a heavy batch job. It means not frequent, but each execution is heavy and slow. High executions, high elapsed time equal to this is your smoking gun. It means this is the real problem. It runs too often and takes too long each time. Now let's go back to our banking example. Look at the first row. This SQL ran 450,000 times. Each execution took about 0.03 seconds, and it consumed 43% of total database time. This is a classic case of death by 1,000 cuts. Now let's look at what this SQL is doing. It is updating a table to generate sequence numbers. And here is the problem. Every single transaction is updating the same row. So imagine this: hundreds of thousands of transactions all trying to update one single row at the same time. That is exactly where your row lock contention is coming from. The fix is simple. Instead of using a table, use an Oracle sequence. Create a sequence and fetch the next value directly. This change took just a few minutes to implement, but the impact was massive. Response time dropped from 8.7 seconds to 0.03 seconds. Throughput increased significantly, and user complaints stopped almost immediately. One SQL statement, one design mistake, massive business impact, and we found it in under 5 minutes just by focusing on the right sections. Now let's move to sections 4 and 5. These sections are all about configuration checks. Section 4. Instance efficiency percentages. Think of these as your database vital signs. You will see numbers like buffer cache hit ratio, library cache hit ratio, purge CPU to purge elapsed. Now you don't need to memorize everything. Just remember a few key thresholds. If buffer cache hit is below 95%, it means cache may be undersized or SQL is inefficient. If library cache hit is below 95%, it means too much hard purging. If purge CPU to elapsed is below 80%, it means possible latch contention. If soft purge is below 90%, it means missing bind variables. In this example, the library cache hit ratio is 89.5%. That is below the recommended level, which means hard purging is happening frequently. In simple terms, the application is not reusing SQL properly. It is parsing the same statements again and again. Section 5. Top segments by physical reads. Now let's look at section 5. This tells you which tables and indexes are generating the most I/O. If you see a table with very high physical reads, it means the database is reading from disk again and again. And you have a few options to fix that. Add a proper index, or partition the table, or cache it using the keep buffer pool. If you see an index in this list, it usually means index access is expensive. You may need to review the access path or consider a different indexing strategy. And that's it. These are the 5 key sections you need to focus on to quickly diagnose performance issues. Now let me show you the script that can automate this entire process. Alright, now I am going to walk you through the AWR Auto-Triage script step by step. You can download this script for free from the GitHub link in the description. Let's start with how the script works and what kind of output it generates. First, connect to the database using the sysdba privileges. Then go to your SQL prompt and run the script. As soon as you run it, you will see the script header displayed on the screen. After that, the script lists all the available AWR snapshots from the last 7 days. Next, it will prompt you to enter the begin snapshot ID and end snapshot ID. Once you provide these values, the script automatically starts extracting all 5 key sections from the database. Section 1, output load profile. This section gives you a quick view of overall database load. Section 2, output top 5 timed foreground events. Here is where it gets interesting. The script automatically highlights the top wait event shows a decoder ring for interpretation, and even provides diagnosis recommendations. Section 3 output top 10 SQL by elapsed time. Notice how clean and easy this output is. The script does all the calculations for you and even shows a preview of the SQL text. Section 4 output instance efficiency percentages. These sections help identify configuration issues. Each metric is compared against real production thresholds. Green check marks healthy, red cross needs attention. Section 5 top segments by physical reads. Finally, the script shows you exactly which tables and indexes are causing high I/O. And the best part, it also gives recommendations for each one. Final output. The script then summarizes everything into clear next steps. For example, if load is high, fix the top weight event immediately. If one event dominates, focus on root cause and related SQL. If efficiency metrics fail, review configuration. If segments shows high I/O, follow optimization recommendation. And that's it. A complete performance analysis with clear recommendations in under 5 minutes. Alright, let's quickly recap what we covered today. First, the 5-minute AWR triage method. Load profile tells you if there is a problem. Top 5 events shows what type of problem it is. Top SQL identifies which queries are responsible. Efficiency percentages highlights configuration issues. Top segments shows which objects are involved. Second, we walked through a real production incident, a banking system, a 2 a.m. call, transaction taking 8.7 seconds, and the root cause, row log contention, fixed in just a few minutes. Third, I showed you the AWR Auto-Triage script. It automates the entire analysis, uses production tested thresholds, provides built-in recommendations, and works across versions from 12c to 23 AI. Now, if you found this useful, here is what I would like you to do. Hit the like button if this helped you understand AWR better. Subscribe for more Oracle DB performance content. Download the script from the link in the description and drop a comment. I would love to know your biggest AWR challenge. Remember this, the best performing database don't rely on the newest features. They get the fundamentals right. Master AWR analysis, master the 5-minute triage method, and those late night protection calls will become much less frequent. Thanks for watching. I will see you in the next video.